Welcome back to the Sabtech machine channel. In previous episodes, we talked extensively about preventing foam core burning through management control and formulation optimization. These traditional methods are mature and proven. However, low-density flexible PU foam demands extremely high operational precision. Even a small deviation can introduce serious safety risks. Today, we'll introduce 3 industry-leading, hardcore technologies. They not only provide stronger safety protection for low-density foam, but also improve overall production efficiency at a fundamental level. 1. Vacuum pressure foaming, VPF, a wider safety margin. Under normal atmospheric conditions, producing low-density foam usually requires higher water content, which significantly narrows the safe processing window. Vacuum pressure foaming changes the ambient pressure through vacuum equipment, giving operators much more room for control. Technical value, VPF allows you to achieve the target density with less water. Lower water means less reaction heat at the source, naturally increasing the safety margin. Production line value, even for high-density products, VPF eliminates the influence of weather and altitude, ensuring highly consistent quality across every batch. 2. Liquid carbon dioxide foaming, LCD, active physical temperature control. This is an extremely efficient cooling-oriented foaming technology. Technical value, when liquid carbon dioxide is injected and vaporizes, it absorbs a large amount of latent heat. For formulations that are highly sensitive to exothermic reactions, it works like a built-in cooling system, keeping the core temperature within a much safer range. Production line value, its cost advantage is equally significant. 4 parts of carbon dioxide can replace 13 parts of MC, greatly reducing raw material costs, while also producing foam that feels softer and more environmentally friendly. 3. Forced cooling technology, breaking the physical heat dissipation limit. Foam naturally retains heat. Relying solely on natural cooling is slow and unpredictable. Forced cooling breaks this physical limitation through active mechanical means. Technical value, customized cooling tunnels forcibly remove trapped heat from the foam core. This is not only about preventing self-ignition, it's about winning time. Production line value, it significantly shortens the curing cycle for all foam products. Foam blocks that previously required a full day before cutting can now enter the next process within just a few hours. This directly doubles warehouse turnover and dramatically boosts factory output. So, how should a factory choose? Each technology has its strengths. The right choice depends on your production scale and core priorities. If you pursue maximum production stability and want consistent, all-weather output, vacuum pressure foaming is the best solution. If your focus is environmental performance and raw material cost control, and you aim to reduce MC usage, liquid carbon dioxide foaming is more suitable. If you want the lowest investment threshold to quickly solve heat dissipation issues and improve warehouse turnover, forced cooling systems are the most practical upgrade. Advanced technologies are only tools. Management is the real key to safety. In the final episode, I'll condense everything into a practical anti-scorching SOP manual that you can take directly back to your workshop. Follow us, and I'll see you in the final episode.